With a chapter called thermal expansion. Those who have joined today, one lecture will be required extra for you all to do the previous part of this chapter, which is thermometry. But what I am going to start right now, it is totally independent of the previous any chapter. Heading right, thermal expansion. What is meaning of word thermal?
Heat.
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 Expansion means what? Contract or elongate?
Elongate.
Elongate.
Elongate, correct. Now imagine this is one wire. If I suspend a load here, will it elongate or it will contract?
Elongate.
It will elongate.
Definitely it will elongate. Definitely it will elongate. But this elongation is not due to heating. This is due to load suspended. What is this property called?
Elasticity.
Elasticity, yes. So don't confuse yourself with elongation of two different phenomena. One is by heating, other is by pulling or by applying force at the free end. So if this is one body, I heat it, then due to rise in temperature, it will show expansion. That expansion is called thermal expansion. So can I say when change in temperature of body changes its dimension, then increase in dimension due to increase in temperature is called as thermal expansion?
Yes, sir.
So what is thermal expansion? Increase in the dimension by increasing temperature is called thermal expansion. See, we are talking about isotropic expansion. That means from left, right, up, bottom, it is expanding by same percentage. That meaning if length is increased by 1%, breadth will also increase by 1%. Height will also increase by 1%. That is called isotropic expansion. Once again, see what is thermal expansion. The increase in the dimension of the body by increasing its temperature is called as thermal expansion. Followed, what is thermal expansion?
Yes, sir.
Right, first line. The increase in dimensions of a body by increasing its temperature. The increase in dimension of a body by increasing its temperature is called as thermal expansion. The increase in dimensions of a body by increasing its temperature is called as thermal expansion. There are three types of thermal expansion. Anybody knows what are three types of thermal expansion? This you might have done in lower class. What are
Area expansion.
Linear expansion.
first length increases is called linear expansion. And after linear, which expansion you know?
Area.
Aerial expansion. Aerial expansion is also called as sometimes superficial expansion. Aerial expansion or superficial expansion. And what is third expansion?
Volume.
volume expansion. Any other name you recollect? It is also called as cubical expansion. So in this chapter, we have to study these three types of expansion: linear, aerial or superficial, volume or cubical. Please write this much. Then we'll see one by one what are these three different types of expansion and relation between them. Yes, completed. Right?
Yes, ma'am.
Okay, everybody has done. The increase in dimension of body by increasing its temperature is called as thermal expansion. There are three types of thermal expansion: linear expansion, aerial is also called as superficial, volume is also called as cubical. Yeah, shall I clear this?
Yes, sir.
See, very simple topic. One MCQ is based on this, so you can score easily in this chapter. Now we are dealing with what is linear expansion in detail and some relation. Linear expansion. What is linear expansion? Expansion in length or in area?
Length.
Length, correct.
Length.
Yeah, correct. So expansion in length due to thermal energy. That means heat energy. The expansion in length due to thermal energy is called as linear expansion. Don't write anything, just wait. Suppose I have got 100 rupees, my friend is having 200 rupees. We both got 50% hike in our pocket money. So what should be my amount become?
150.
150. And his amount?
250.
250 नहीं, 300 होगा.
300. 300. Yes.
50% मतलब 100 में 50. So 200 में उसका 100 बढ़ेगा ना, तो 300 रुपीस हो जाएगा, बराबर?
Yes, sir.
तो किसका ज्यादा बड़ा पैसा?
The second one.
सेकंड वाले का. मतलब ओरिजिनली इफ लेंथ इज मोर, then definitely increase will be more.
More, yes, sir.
Suppose I take 4 centimeter long rod, another one same material but 5 centimeter, another one same material but 10 centimeter. All I heat, by 10 degrees Celsius. All. Who will show more expansion?
The third one, 10
Third
square.
one, because its original length is more.
More, yes.
Suppose all are of same length. Have you written this much? Expansion in length due to thermal energy is called linear expansion.
Yes, sir.
Yes, sir.
Now खाली सोच के बोलते रहे ना. I took same material but different length. You said longest one will expand more, correct?
Yes, sir.
Very good. This is perfectly right. Longest will expand maximum. All are of same length. Same length I have taken now. But one I heat by 10, other I heat by 20, other heat by 30. Who will expand more?
With
30.
more temperature.
More temperature.
More temperature. So logically I get idea, if L0 is original length at 0 degrees Celsius and LT is length at T degrees Celsius, then LT minus L0 is increase in length or not?
Yes, sir.
This will depend upon original length at 0 and the temperature by which it has been heated. Same concept if you recollect you did in current electricity. So increase in length is directly proportional to original length and depends upon temperature. So can I say LT minus L0 is proportional to original length and rise in temperature together?
Yes, sir.
So LT minus L0 is equals to some constant into L0 delta T. This alpha is a constant called as coefficient of linear expansion. What is name of alpha?
Coefficient of linear
Of
expansion.
linear expansion.
So alpha will become LT minus L0 upon L0 delta T or not?
Yes, sir.
This is called coefficient of linear expansion. So in exam they can ask, define coefficient of linear expansion, state its SI unit. State its SI unit. Now see how to start. First I'm obtaining the formula for alpha, then I will give you definition. What is linear expansion? Expansion in length due to thermal energy is called thermal expansion. Say what is linear expansion? Expansion in the length due to
the energy.
which
Thermal
energy?
energy.
It's
Thermal
called as
energy is
linear
called.
expansion. It's called as linear expansion. Now we are interested in getting that alpha. Consider very simple topic, very easy. Just be careful. It is easy to understand. Consider a metal rod having length L0 at 0 degrees Celsius. Let its length becomes LT at T degree Celsius. Therefore, increase in length equals to LT minus L0. The increase in length LT minus L0 is directly proportional to its original length at 0 degrees Celsius. In bracket you can write L0 and rise in temperature delta T. So sometimes they can ask derive expression for coefficient of linear expansion. Define given, no need to write this. So consider a metal rod having length L0 at 0 degrees Celsius. Let its length becomes LT at T degree. So increase in length is LT minus L0. The increase in length LT minus L0 is directly proportional to original length at 0 degrees Celsius, that is L0, and rise in temperature delta T. So I can write therefore LT minus L0 is proportional to L0 into delta T. Therefore, LT minus L0 is equals to some constant into L0 delta T, where alpha is a constant called as coefficient of linear expansion. Alpha is a constant called as coefficient of linear expansion. Any doubt till this?
No, sir.
Please copy till this. Consider a metal rod having length L0 at 0 degrees Celsius. Let its length becomes LT at T degrees Celsius. So increase in length equals to LT minus L0. The increase in length LT minus L0 is directly proportional to its original length at 0 degrees Celsius, which is L0, and rise in temperature delta T. Yes, Vaibhav, you followed?
Yes, sir.
Very simple topic. As I said, this is totally independent of any other chapter.
That's
Consider metal rod having length L0 at 0 degrees Celsius. Let its length becomes LT at T degree. Increase in length is LT minus L0. So increase in length is directly proportional to the original length at 0 degree and rise in temperature. Therefore, it is proportional to L0 delta T, which is equals to alpha L0 delta T. Alpha is a constant called as coefficient of linear expansion. Can I clear everything now?
Yes, sir.
Okay. Therefore, alpha equals to LT minus L0 upon L0 delta T. So if there's a derive expression for coefficient of linear expansion, then this much you have to do. Now define coefficient of linear expansion. Define coefficient of linear expansion. Since alpha equals to LT minus L0 upon L0 delta T. So can I say like this? Coefficient of linear expansion is defined as increase in original length. What is LT minus L0? Increase in original length, correct?
Yes,
sir.
sir.
This line can I say per unit original length at 0 degrees Celsius per degree rise in
Rise
temperature.
in temperature.
Upon is called per. So increase in original length per unit original length at 0 degrees Celsius per degree rise in temperature. Okay, clear? What is coefficient of linear expansion?
Yes, sir.
Yes, sir.
So I can say it is defined as increase in original length. It is defined as increase in original length, comma, per unit original length at 0 degree Celsius, comma, per degree rise in temperature. It is defined as increase in original length per unit original length at 0 degree Celsius per degree rise in temperature. Please write this much. Once you complete writing, please guide me so that I can move ahead. It is defined as increase in original length per unit original length at 0 degree Celsius per degree rise in temperature.
Done, sir.
It's SI unit is. Can you tell me what will be unit of change in length? Meter, na?
Meter.
Meter.
Meters. Yes.
No, per second, nahi, only meter. Change in length is meter, and length is also in meter. So meter will get cancelled. So whatever is the unit of this temperature, same will be the unit of alpha in reciprocal. So can I say
Yes, sir.
SI unit is per Kelvin? What is SI unit?
Per Kelvin.
Per
Kelvin raised to minus.
or K raised to minus 1. But usually it is taken as per degree Celsius, because when you take difference of Kelvin and Celsius remains same. So if they say SI unit, it is per Kelvin or Kelvin raised to minus 1. But usually in day-to-day numerical, it is taken as per degree Celsius. Right, it's 2 point. Is completed.
Yes, sir.
Note. Since alpha is LT minus L0 upon L0 delta T, therefore LT minus L0 is alpha L0 delta T. So LT is L0 plus alpha L0 delta T. LT equals to L0 I can take common, 1 plus alpha delta T. So that means length at any temperature can be written as L0 1 plus alpha delta T. So whenever they say find the length at 10 degree, 20 degree, 30 degree, directly I'll be using this formula. Now copy till this. Yeah, shall I clear it off?
Yes, sir.
Second point. See, all notes are for numerical or MCQs. Huh? If L1 comma L2. Now I have not taken original as 0 degree. As if L1 comma L2 are lengths at T1 degrees Celsius and T2 degrees Celsius, where T2 is greater than T1, then delta T is T2 minus T1, and we can write L2 equals to L1 1 plus alpha delta. So we can, because alpha doesn't changes that rapidly, so we can relate with any length. Higher temperature length is lower temperature length 1 plus alpha delta T. So second point, write down. Not necessary every time starting temperature is 0.
Done, sir.
Yeah, no problem. And write areal expansion. Linear expansion was increase in length by heating or thermal energy. So areal expansion will be what? The increase in length or increase in area?
Increasing area.
In area.
So the increase, एकदम simple, same word. The increase in surface area, to be more precise. The increase in surface area on heating is called as aerial, or please remember this name also, or superficial expansion. Increase in surface area on heating is called as aerial or superficial expansion. Consider a metal plate having surface area A0 at 0 degrees Celsius and AT at T degrees Celsius. Therefore, increase in area equals to AT minus A0. The increase in area is directly proportional to the original area at 0 degrees Celsius. In bracket I am writing A0 and rise in temperature delta T. Therefore, AT minus A0 proportional A0 delta T. Therefore, AT minus A0 is equals to. Now, this constant we denote by beta, not alpha. A0 delta T. See, this is proportional sign written as equal to beta, where beta is a constant called as coefficient of aerial expansion. I hope you followed this also.
Yes,
Yes,
sir.
sir.
Please write from aerial expansion. The increase in surface area on heating is called as aerial or superficial expansion. Yes, completed.
Yes, sir.
So we got coefficient of areal expansion denoted as beta. Shall I clear this?
Yes, sir.
Okay. So beta becomes AT minus A0 upon A0 delta T. Define coefficient of areal or superficial expansion. Again, I'm not changing my word, just length will become area. So it is defined as increase in original area, comma, per unit original area at 0 degrees Celsius, comma, per degree rise in temperature. It is defined as increase in original area. This line means per unit original area at 0 degrees Celsius per degree rise in temperature. Its SI unit is, again we'll write by same method, is per Kelvin, that is Kelvin raised to -1. Usually it is taken as per degree Celsius. Write this much. So if they ask SI, then you will write Kelvin. If they just say unit, you can write either Kelvin or per degree Celsius. Once you complete, please tell.
Done, sir.
Again, same history. Note. Now directly I am writing AT equals to A naught 1 plus beta delta T. Or we can write A2 equals to A1 1 plus beta delta T. In this case, delta T is T minus 0, which is T, and here delta T will be T2 minus T. Can I clear this also?
Yes, sir.
So we got linear expansion, we got areal expansion, we got alpha, we got beta. Now third part, volume expansion. Length was increase in length, area was increase in area. So volume will be the increase in volume. The increase in volume, the increase in volume due to heating is called as volume expansion or cubical expansion. I said easy because whatever we are doing for length, same we do for area, same we do for volume with small changes. Right? Volume expansion meaning increase in volume due to heating is called as volume expansion or cubical expansion. Can I clear this now?
Yes, sir.
Consider a cubical metal having volume P0 at 0 degrees Celsius. Let Vt be the volume at T degrees Celsius. Therefore, increase in volume equals to Vt minus V0. The increase in volume Vt minus V0 is directly proportional to the original volume V naught at 0 degrees Celsius and rise in temperature delta t. Therefore, Vt minus V0 proportional V0 delta t. So Vt minus V0 equals to gamma V0 delta t, where gamma is a constant called as coefficient of cubical expansion. Right. So if they say derive formula for gamma, then you have to go this much. Gamma is a constant called as coefficient of cubical or volume expansion. Consider a cubical metal having volume V0 at 0 degrees Celsius. Let V0 be the Vt be the volume at T degree. So increase in volume equals to Vt minus V0.
Sir, can I leave?
Yes, yes.
Done, sir.
Okay. Therefore, we can say gamma equals to Vt minus V0 upon V0 delta T. So if they say define coefficient of cubical or volume expansion, all the three definitions are similar. That's why this chapter is bit easy. Whatever we do for length, similarly you have to proceed for area, same way for volume. It is defined as increase in original volume, comma, per unit original volume at 0 degrees Celsius, comma, per degree rise in temperature. Its SI unit is per Kelvin. Per Kelvin, that is K raised to minus 1. It is usually taken as per degree Celsius. Right.
Done, sir.
One small part relation between alpha and beta will do, then we'll stop. Can I clear this everything?
Yes, sir.
Yes, sir.
Ekdam simple. Again, relation between alpha and beta. Obtain the relation between alpha and beta. What is alpha?
Coefficient of linear expansion.
Linear expansion. And beta?
Coefficient of error expansion.
Areal expansion or superficial expansion. We want to obtain relation between alpha and beta. Alpha is related to length, beta is related to area. So I'm saying consider a square metal plate, so that area will be simple side square. If you take any other shape, then it will become length into breadth. So consider a square metal plate having length L0 at 0 degrees Celsius and LT at T degrees Celsius. Let A naught, comma AP be the surface areas at 0 degrees Celsius and T degrees Celsius respectively. Therefore, A naught is side square because area of square is side square, and AT equals to LT square. I hope this to follow. Area is side
Yes, sir.
square, so
Yes,
L0
sir.
square and LT square. Okay. Now we know that LT equals to L0, 1 plus alpha delta T. How this LT will become LT square? Can I say squaring both sides? If I square both sides, then left hand side will become LT square. See, this is not L and T two term. It is suffix, like we write A1, A2, A3. Therefore, it is LT here. L0 square 1 plus alpha delta T the whole square. LT square is L0 square. I think we all know what is formula for A plus B the whole square.
Yes, sir.
It is A square. So here 1 square, that is 1 plus 2 alpha delta T plus alpha square delta T square. Okay, this much clear?
Yes,
Yes,
sir.
sir.
Just
Yes,
copy
sir.
this much first.
Done, sir.
Everybody is done till this?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. थोड़ा सही बात है. Tension.
Okay.
Now LT square I can write 80. L naught square I can write A naught 1 plus 2 times alpha delta t plus alpha square delta t square. Since alpha is very small, when we say very small, we are talking about value less than 1, but positive. What is 0.1 ka square?
0.01.
Is it lesser than 0.1?
Yes.
Yes. So whenever you square, take cube of number less than 1, then higher power will become lesser. So since alpha is very small, therefore neglecting alpha square delta t square, we get at equal to a0 1 plus 2 alpha delta t. So at upon a0 is 1 plus 2 alpha delta t. That means at upon a0 minus 1 is 2 alpha delta t. So at minus a0 upon a0 is 2 alpha delta t. So I can say at minus a0 upon a0 delta t is 2 alpha. What is this quantity called as?
Beta.
Beta.
Beta, correct. So this is beta equals to 2 alpha. This is relation between coefficient of linear and superficial expansion. Beta equals to 2 alpha. Okay, everybody cleared now this one?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yeah, please copy.
So, sir, we can use this relation, right? Whenever in the numericals.
That's why we are proving. See, theory is not that difficult in this chapter, but numerical will be slightly tricky because you have to adjust many things. So whenever they don't give you beta, but they have given alpha, you can always say beta is twice alpha. Okay, everybody is done?
Yes,
Yes.
sir.
Yes,
Uh,
sir.
Not yet.
Done, sir.
Yes, sir. Yes, done.
So that's all for today. Avan, you wait for 2 minutes, we'll discuss. Rest all students, same next lecture on Saturday at 9 o'clock sharp. Or 9:10 I will start so that your lecture is not getting class.